Hello, my name is Diego Llano, and I will be talking about the effects of autonomous vehicles on infrastructure investment. This video is for the class, The Open Road, at Stanford GSV with Professor Keith Hennessy. Autonomous vehicles will be a reality sooner than later, and we have to be prepared if we want to capture all of the benefits that entails, such as increased safety, reduced emissions, and reduced traffic. Vehicle-to-infrastructure communications will enable a maximum efficiency and safety, but they will also demand important upgrades in our road systems and our telecom infrastructure. The U.S. transportation and highway systems have been underfunded for decades, and their poor performance is costing U.S. citizens and businesses hundreds of billions of dollars a year. 42% of highways are congested, and 32% of roads are in poor condition. In addition, between the year 2000 and 2013, the capacity of the highway system only grew by 5.3%, while the number of drivers grew by 11%. These figures illustrate how challenging it is going to be to modernize and adapt our highway systems to better suit autonomous vehicles. As I said before, vehicle-to-infrastructure communications will be essential to achieve maximum safety and efficiency. This means that our roads will have to be equipped with all sorts of sophisticated equipment, such as roadside units, sensors, smart traffic lights, and road lines with metallic meshes. On the screen, we can see a typical example of a vehicle-to-infrastructure communication. It is hard to predict how our cities will change and what they will look like in the future. Currently, OEMs are developing autonomous vehicles through self-contained strategies. This means that they are developing systems that will allow them to deploy the vehicles before infrastructure changes. As a result, massive amounts of data will start getting generated, and this will be a very powerful tool for designing and modernizing our roads. So in other words, the data generated by cars will drive the design and modernization of our road systems. The big question is then, who will own all this data? Is it going to be OEMs, TNCs, the government, telecom? And most importantly, who do we trust with all this data? The telecom industry will also face big challenges and opportunities. The billions of devices that will come online as a result of the Internet of Things, of autonomous vehicles, and smart cities will put a lot of pressure on existing infrastructure such as antennas, cables, and data centers. The channel for media transfer of autonomous vehicles is still a battleground and ownership is still unknown. Currently, OEMs use a mix of dedicated short-range communications and LTE to power their vehicles. However, some experts suggest that the deployment of 5G networks might be a game changer. It is likely that the telecom industry will continue to consolidate and big players will continue to acquire startups that are developing these technologies. But as I said, there are still a lot of questions in the air regarding this topic. The cost of building a new highway can go anywhere from $3 million per mile to $10 million per mile. So the cost of adding a couple of new sensors and smart traffic lights is marginal. However, we have already discussed the systematic underfunding of the highway system. The graph on the left shows the declining GDP percentage that has been spent on highways, and the chart on the right shows the projected deficit of the Federal Highway Trust Fund for the next 5 years. A potential solution is a vehicle miles traveled tax. This would supplement or substitute the current fuel taxes that fund the Federal Highway Trust Fund. Although this is an attractive solution, there is also some pushback from electrical vehicle owners who would be punished the most by this tax. Private sector participation will be critical to finance, develop, and maintain the necessary infrastructure. OEMs and telecom companies may be inclined to use their own funds to develop such infrastructure. We have seen this before in the mobile phone revolution, where telecom companies use device sales to finance towers, cables, and the necessary infrastructure. So a scenario where OEMs and telecom companies partner up to provide the necessary infrastructure is not unlikely. On the other hand, private investment funds may want to participate in the space through public-private partnerships. It has been proven that assets owned and operated by the private sector are in better conditions and perform better. So private sector participation will be critical to access funds and expertise. Several initiatives are helping overcome these challenges and make progress in the deployment of smart infrastructure. For example, the Smart City Challenge of the Department of Transportation granted the City of Columbus in 2016 a $40 million grant to execute their Smart City plan. In Boston, smart traffic lights and smart parking spots have been deployed in critical areas of town to help users save time in their commute. Other cities like Denver, Pittsburgh, San Francisco, and Atlanta are also incorporating smart city designs into their infrastructure plans. Despite the progress being made, there are several challenges going forward. Policymakers must focus their attention on the following issues. First, maximizing the efficiency of current networks. So rather than building new miles of highways, we must find ways to increase the use and improve the performance of existing roads. Second, alleviating the systematic underfunding of the Federal Highway Trust Fund. Designing and updating ownership models for infrastructure to capture the full benefits of private participation, as well as fixing the current inefficiencies of taxation models, will be key to achieving this goal. Third, setting in place the right mechanisms to ensure fair market competition and sufficient access and security for the data generated. The amount of data generated and transferred will create a big market opportunity for telecom companies as well as OEMs and TNCs. The right economic and legal conditions must be in place to ensure an optimal development of these networks. And lastly, autonomous vehicles, in the long run, will likely increase the amount of time people are willing to spend in their vehicles and decrease traffic, therefore leading to urban sprawl. If we want to live in a sustainable future, policymakers must find ways to counterbalance the adverse effects of urban sprawl. Alright, thanks for watching this video. Please contact me if you have any questions or comments. Thanks!